Hello students, now we are going to start problem based on 6th unit, which is thermodynamics. 6th unit of crash course, which is thermodynamics. Thermodynamics. First question is from AIPMT 1988. What is first law of thermodynamics? Is a consequence of conservation of, we know that what energy we are getting from the source dq is equals to du plus dw. Whole is utilized in either in increasing the internal energy or doing in external work. Means energy intake is equals to energy output. What we are doing, dq is equals to du plus dw. No energy is going any another way. So we are saying that it is a form of law of conservation of energy, because we are adding the energy what we got from source and what is utilized energy du plus dw. Both should be equal. Second, a thermodynamic process is shown in the figure. The pressure and volumes corresponding to some points in the figure are PA is given, PB is given, VA is given, VD is given. In process AB, 600 joule of heat is added to the system, and in process BC, 200 joule of heat is added to the system. The change in internal energy of the system in process AC would. We know that change in internal energy is not a path function. You go from A to C by any path, change of internal energy should be same. Data is given. From the path, we can move from A to D, we can move from D to C. Change in energy should be equal in both cases. So what we will do, we will apply first law of thermodynamics. dq is equals to du plus dw. From which path they gave us dq, we will check that. In the process AB, they gave with this path AB. In process AB, system absorbs 600 joule of heat. So in this process, dq should be positive, because heat system, we added heat to system absorbed the heat. So dq should be positive, and it is plus 600 joule. From B to C, again dq is positive. What they are saying, in process BC, we added 200 joule of heat to the system, means system absorbed the heat, so it should be positive. So first I am applying this rule, dq is equals to dw in from A to B in this path. dq, what is dq? dq is A to B 600 joule positive. What is du? We have to calculate dw 0. Why dw 0? Because when you are moving from A to B, your line is perpendicular to the volume axis, means volume at A and B are same. So change in volume is 0. So A to B work done should be 0. It means when you move from A to B, internal energy is increased by 600 joule. du is positive, means increased by this amount. Now we are moving from B to C. Again applying this rule, what is dq? dq is plus 200 joule. We will calculate du. dq is equals to du plus dw. What is dw? dw means work done from B to C. Work done is, pressure is constant, so we can apply the formula pressure into change in volume. So it means 200 is equals to du plus, what is pressure? B and C, pressure is same and it is given in SI unit, 8 into 10 to the power 4 Pascal. Pascal means Newton per meter square, SI unit. Change in volume. Volume at A, volume at B and A same, and it is 2 into 10 to the power minus 3 meter cube. And at C, it is 5 into 10 to the power minus 3. So what is the change in volume from B to C? 5 into 10 to the power minus 3 minus 2 into 10 to the power minus 3. It means 5 minus 2, 3 into 10 to the power minus 3. So what we are getting now? 200 is equals to du plus 8 into 3, 24. 10 to the power minus 3 and minus plus 4 and minus 3 plus 1. So what we are getting, du is equals to 60 joule, again plus, means when you are moving from A to B, internal energy is increasing by 600 joule. It is increasing by 600 joule. When 200 and it is 240. When we are moving from B to C, again internal energy is increasing by 60 joule. From A to B, it is increased by 600 joule because system was absorbing. It is PA is 8 into 10 to the power 4. At PB pressure is not 3. At PB the pressure is 8 into 10 to the power minus 3. At pressure P at B, it is given PB is not 3, it is 8 into 10 to the power 4, 8. So 8 into 8, it should be 8 into 8. It means it is 64, 640. So when we are moving from B to C, we add 200 joule of energy, and B to C work done is, pressure is 8 into 10 to the power 4 Pascal, 8 into 10 to the power 4 Pascal, and volume is increasing by 5 minus 2, it is 3 into 10 to the power minus 3. So it means 24, it is 24, 240. Again we are getting same 240 joule. So in this process, change in internal energy should be 60 joule. So it means when we are moving from A to B, there is change in potential energy, there is change in internal energy. Then it is by 600 joule, because A to B we didn't do any work, volume change in volume was 0. So whole supplied energy was used in increasing the internal energy. And from this process, when we were moved from B to C, we add 200 joule. But in that 200 joule, 240 joule is spent in doing external work. So remaining, it should be 60 joule. So 200 minus 240, it means internal energy is decreasing by minus 40 joule. 200 minus 240 means minus 40 joule. So first energy increased by 600, then decreased by minus 40. So total change should be 600 minus 40 means 560 joule. So we will go with A option, 560 joule. Next, it is again from 1992 AIPMT. A thermodynamic system is taken from state A to state B along the path ACB. Means we are moving in this way, A to B through the path ACB, and is brought back to A along BDA. Along BDA we can back this. It means initial point and final point is same. So change in internal energy 0, but work done was there. You know that I told you in theory sheets that if there is a closed loop, area under the loop will define the work done. Since it is a closed loop, so area enclosed between A, C, B, D, A, it should be work done. So now work done is defined by the loop A, C, B, D, A. So we are going with option C. If it is not a closed loop, then you have to take area enclosed by the curve with volume axis. It will give you work done. It will give you work done. But if it is a closed loop, area under the loop will define work done. So we are going with C option. Next, it is from 1993 AIPMT. What they are saying, an ideal gas A and a real gas B have their volume increased from V to 2V under isothermal condition. The increase in internal energy. I told you initially that internal energy is a function of temperature, but what we define initially in theory, that all was for ideal gas. So if you are not increasing the temperature, internal energy of ideal gas will not increase. But for real gas, it is not true, because at the time of derivation, we ignore the intermolecular attraction. We assumed in our assumption in kinetic theory of gases that molecules are not attracting each other, but in real gas, molecules are attracting each other. So it should not be same in both cases. It will change in case of real gas, but it will not change in case of ideal gas. Ideal gas, if temperature is constant, the increase in internal energy will be 0. Will be, what they are saying, will be same in both A and B? No. Will be 0 in both case? No. Of B will be more than that of A. A was ideal gas, it was 0. So we will go with option C. Next, it is from 1993. Which of the following is not a thermodynamical function? All of you knows that work done is a path function. That's why it is not a thermodynamical function. So we will go with option B. Next, it is from 1993 AIPMT. 110 joule of heat is added to a gaseous system whose internal energy change is 40 joule. They are saying plus 40 joule means internal energy is increasing. Then the amount of external work done is, problem was very simple. Direct the application of first law of thermodynamics. dq is equals to du plus dw. I told you about the sign convention. If system is absorbing heat, heat should be positive. If system is doing work, work should be positive. Because if system means gas, gas is absorbing heat. Definitely it will expand. If gas is expanding, means volume is increasing, means change in volume is positive, and pressure into change in volume is work done, so work done should be positive. So learn in this manner, if you are moving from left to right, dq and dw both are positive, means system is absorbing heat and doing external work, both should be positive. But if reverse procedure is there, you are working on system and system is giving you heat, both should be negative. So what is happening here? We added heat to the system, so dq is plus 110 joule. Internal energy increased, so du should be positive, change should be positive. So putting the values, 110 is equals to 40 plus dw, what we are getting? Work done should be 70 joule. So it means we should go with option B. Next, it is from 1998 AIPMT. We consider a thermodynamic system if delta U represents the increase in its internal energy and W is the work done by the system. Which of the following statement is true? What is A? First we write what law. We know dq is equals to du plus dw. First is adiabatic process. We know that in adiabatic process, system neither absorbs nor liberate heat. So dq should be 0. If dq is 0 and system is doing work, it will use its internal energy. So it means internal energy will decrease. So du should be equal to minus dw. So we got our answer. First statement is true. In isothermal process, no change in internal energy. In isothermal change, du is 0, so dq is equals to dw. C is wrong. Delta U is equals to W. In adiabatic process, no, it is minus dw. So we are going with A only. Next is again from 1998. The ratio of specific heats of a gas at constant pressure to that of constant volume means Cp upon Cv is gamma. The change in internal energy of the given of mass of the gas when the volume changes from V to 2V. What we are saying, when volume is changing from V to 2V at constant pressure, we know that what is the concept behind this? Change in internal energy. It is mu into Cv into delta T. Why we are saying this? Because when at constant volume, what energy you are supplying to system, that is only utilized in increasing the internal energy. And you know that heat absorbed or heat liberated. In calorimetry we studied what is it? ms theta. For gas, mass means number of moles. Specific heat C. Theta means change in temperature. So heat absorbed you can calculate by what? Mu into C into delta T. But if you are using Cv, gas has two specific heats. Cv means at constant volume. If volume is constant, it means system there is no external work, whole heat absorbed is used in increasing the internal energy. So we can write Q is equals to delta U. And you know that what is gamma? Gamma is Cp upon Cv is equals to gamma. And we know that 1 plus R upon Cv, you know Mayer's formula, it is also gamma. 1 plus R upon Cv is also gamma. So we can calculate Cv. So what is Cv? We can calculate, take this one on that side. So you will get gamma Cv is equals to R upon gamma minus 1. So now using this in this, we calculate the delta U. It is mu means number of moles into Cv. In place of Cv, what we are going to write, R upon gamma minus 1 into delta T. Delta T means change in temperature. Delta T means change in temperature. And what is given to us? Change in temperature we can calculate from change in volume is from V to 2V. We know that gas formula, gas equation, PV is equals to mu into RT. Initially P was P, volume was V, temperature we are taking, initial temperature suppose T1, pressure was again P, volume was 2V, temperature you can take T2. So subtract first equation from second equation, you will get PV is equals to mu R into T2 minus T1 means delta T. So in this way we can calculate delta T, PV upon mu R. So what we are getting this delta U, mu R by gamma minus 1 into mu R upon gamma minus 1, delta T we can write PV upon mu into R. Cancel mu R with mu R. What you are getting? You are getting PV upon gamma minus 1. So we are going with option C. So in this way C option was correct. Next, it is from 2008. AIPMT Q defines change the heat added to system. Change in internal energy is E and work done was W. We discussed in previous questions कि for closed cyclic process, the area under the loop will define work. So work is not zero. What energy you are supplying to system, it will do only work, means Q and W both cannot be zero, only change in internal energy. What we are doing, ki only change in internal energy, because internal energy, change in internal energy is not a path function. From where you started, you end at that point, then you can say it is a cyclic process. Since initial point and final point is same, so change in internal energy should be zero only. It means we will go with A. The internal energy change in a system that has absorbed 2 kilocalories of heat and done 500 joule of work is, it is a problem from 2009 AIPMT. What they are saying, change in internal energy we want to calculate. System absorbed 2 kilocalorie of heat and done 500 joule of work. So only you have to take care of sign convention. First thing, dq is equals to du plus dw. What is dq? dq is not given in joule. Everything is in joule, answer is also in joule. But dq they gave in calories, but you know that 1 calorie means 4.2 joules. 1 calorie means 4.2 joule. So 8 kilocalories, kilo means 1000, calorie means 4.2 joule. So it means dq was, remove decimal with this one 0. 8 2s are 16, 8 4s are 32 and 133. 33600. They are saying 2 kilocalories of heat. It is 2 kilocalorie, not 8. It is 2 kilocalorie. So 2 into kilo means 1000 and 4.8 means we get 8480 joule. So dq was 8400 joule. Since system done the work, so work should be positive, it is 500 joule. So now we are putting values in this. We want to calculate du. Du means dq minus dw. dq was 8400 minus 500. So what we are getting? 7900 joule. So we are going with option D. Now a problem from 1994 AIPMT. In an adiabatic change, the pressure P and temperature T of a monoatomic gas are related by the relation P proportional T raised to the power C, where C equals, I told you in theory sheet, in adiabatic process, gas is following a law which is known as Poisson's law. PV raised to the power gamma is equals to constant. But from gas equation, we know that PV is equals to mu RT. For given quantity of gas, mu is constant, R is constant. We want a relation between P and T. So we want to remove V. So what we can write in place of V? Mu RT divided by P. So now this law will become P. In place of V, I am writing mu RT upon P raised to the power gamma is equals to constant. It means P raised to the power, it is 1 and it is gamma, 1 minus gamma. We are only discussing about P and T into T raised to the power gamma. Mu and R are constant, take constant on that inside. It means constant divided by a constant, new constant, constant multiply by a constant, new constant. So it should be again constant. It means P should be proportional to P raised to the power 1 minus gamma. It should be proportional to T raised to the power minus gamma. Take on that side, transfer power on that side. So what we are getting? P is proportional to T raised to the power minus gamma upon 1 minus gamma. But what they is given there, they are saying no, minus gamma upon 1 minus gamma, it should be equal to C. Take minus common. So we are getting C is equals to gamma upon gamma minus 1. Gamma is given 5 by 3. 5 by 3 minus 1 means 2 by 3. Cancel 3 with 3. So we are getting the value of C 5 by 2. So we are going with option D. So correct option was D, 5 by 2. Next, a diatomic gas initially at 80 degrees centigrade is compressed adiabatically to 1/8 of its original volume. The temperature after compression will be, means process is adiabatic, volume is changed from V to 1/8 of its original V by 8, and we want change in temperature. Temperature after compression means first we have to find a relation between temperature and volume. Again it is a adiabatic process. It means P raised to the power V, P into V raised to the power gamma, it should be constant. But PV is equals to mu RT. So remove We want relation between volume and temperature. So put the value of P, mu RT divided by V into V raised to the power gamma is equals to constant. Mu and R are constant. So what we are getting? V raised to the power gamma minus 1 into T, it should be constant. It is a diatomic gas. What is the value of gamma for diatomic gas? We know that what is gamma? The ratio of specific heats at constant pressure and constant volume, or you can calculate it by degree of freedom. Degree of freedom for diatomic gas is 5. So what we are getting? 1 plus 2 by 5. It is 7 by 5. So what is given now? V. V raised to the power gamma minus 1. Gamma minus 1 means take this 1 on that side, 2 by 5. V raised to the power 2 by 5 into T. It should be constant. Now, initially volume was V and temperature was T. T means absolute temperature. So we have to add 273 in 18, 291. Now volume is V by 8. Cancel V raised to the power 2 by 5 with this. So what we are getting? New temperature we have to calculate. So new temperature should be 8 raised to the power 2 by 5 into 291. It means it is 8 raised to the power 2 is 64 raised to the power 1 by 5 into 291. So now we have to take one approx calculation. We know that 2 raised to the power 5, either we can take the help of log, but log table is not allowed. So in competitive, either they will give you the value of this power 1 by 5. So it is going to be, if it is 1 upon 6, you will get 2 because it is 2 raised to the power 6, but it is 1 upon 5. So you will get a number little bit greater than 2. So approximately you will get a number little bit greater than 582. Means when you subtract 273 to get degree Celsius, greater than this. So removing the option this, not much greater than this. So in this range only one option is there. So we can tick confidently A. So it should be 395.4 degrees Celsius. Next is again from 1996 AIPMT. An ideal gas undergoing adiabatic change has which of the following pressure temperature? We just established pressure temperature relationship. See, it was again one adiabatic change. What relation we got? P raised to the power 1 minus gamma. See, P raised to the power 1 minus gamma into T raised to the power gamma should be 0. P raised to the power 1 minus gamma into T raised to the power gamma. So we are going with B option.